is problem number 8 from section 3.7. In this problem it says the given point is on the curve. Find the lines that are tangent and normal to the curve at the given point. So if we want to find the lines that are tangent and normal, we need to find the slope of that curve at 3, 4. We know the tangent slope is just going to be whatever that slope is, and the normal slope will be the perpendicular slope to that. So let's go ahead and find the derivative first. And notice we don't have an equation that's y as a function of x. This equation has both x and y on the same side. There's really no way to get y by itself, so we're going to go ahead and just use implicit differentiation to take the derivative. So as we go across from left to right, the derivative of x squared is 2x. The derivative of xy, we have to use the product rule, so we're going to say that u equals x, u prime, v prime. So this is v is y, and v prime would be, well, it would be 1 dy over dx because of the derivative of y, and this will just be 1. So the product rule says u prime v, so 1 times y, so I'll end up with plus y plus the 1 dy over dx times x, so that's just x dy over dx, so x dy over dx. So I did the derivative of x squared, then I did the derivative of xy with the product rule, and now I'm doing the derivative of y squared, which is minus 2y dy over dx equals derivative of 5, 0. So what we want to do is we want to move the 2x to this side and the y to this side. So we're going to subtract both of those over. And we get x dy over dx minus 2y dy over dx equals negative 2x minus y. So I can factor out dy over dx, and I get dy over dx x minus 2y equals negative 2x minus y. Now we'll divide this x minus 2y to the other side, and we get dy over dx equals negative 2x minus y over x minus 2y. So this is our derivative for the function. Now I want to find the slope. Let's go ahead and write slope at 3, 4. If I want to do that, I just take dy over dx, and I'm going to plug in 3, 4, and so I get negative 2 times 3 minus 4. All right, we're plugging into this derivative over 3 minus 2 times 4. When we multiply that out, negative 2 times 3, that's negative 6 minus 4 over 3 minus 8. So that's going to equal negative 10 over negative 5, which means the slope for our tangent slope, so we'll say tangent slope, is m equals 2, and our normal slope is perpendicular to that, which is m equals, well, perpendicular to 2, negative reciprocal, so negative 1/2. So now we can use y equals mx plus b. And remember, we're using the point 3, 4. So I'm going to kind of write that here. This is tangent slope at 3, 4, and 3, 4 here. So we've plugged in 2 and the 3 and the 4, so we got 4 equals 2 times 3 plus b. This will be 6, so 4 equals 6 plus b. Subtract the 6, negative 2 equals b. So the tangent line is y equals 2x minus 2. tangent line. The normal line, then we do the same thing. Plug in 4 and 3, so we get 4 equals negative 1/2 times 3 plus b. So 4 equals negative 3/2 plus b. Add that over. This will be 8/2 plus, because that's what 4 is, 8/2 plus 3/2 equals b. So that's 11/2 equals b. So I end up with y equals, this will be negative 1/2 x plus 11/2. This will be the normal slope, or normal line, I mean.